We're going to make an X bar and S chart. The data set I'm looking at follows the ratings that a set of users have given to a browser experience. They are rating their experience on a 1 to 10 scale, and we have 100 observations per day. So first of all, I'm going to have a quick look at the data, and I'll note right now that day is in this data set identified as an ordinal variable, and that's going to be important for one of the plots that I'm going to do. It's not important for quality control in general, but I'll do a plot before I do the quality control charts. So let's just have a look at the data very quickly, which is an analyze fit y by x. Day is the x variable and rating is the y variable. And if we have a quick look at that, that's what the data looks like. So not particularly helpful. The scale was 1 through 10. It's obviously discrete, and it's very hard looking at the raw data to get any sense of a trend. Now, we're interested in tracking the mean over time, and in the context of this question, the process mean that we are going to work with is a mu of equal to 8, and the process standard deviation is going to be 1.2. So we're going to use those parameters later on when we create the X bar and S charts. But for now, we're just looking at the data. So I note that it's really hard to tell what's going on here, but one of the things that I can do is add to this chart the daily means. And I'll do that by right-clicking on the title bar, going to Display Options, and I'm going to do Mean Error Bars. Now, if I were to remove the points, and I can remove the points by right-clicking again, and it's all going to Display Options and removing the points, I can now get a sense of what those daily means are doing. And if I rescaled this plot to say make it go between 7 and 9, for example, on the vertical axis, then it becomes quite clear what's happening to this process, that the mean is increasing over time, so people are getting happier with their experience. Now, in order to create this plot, it was important to have the x variable day recorded as either nominal or ordinal. If you had it as a continuous variable, you wouldn't see this plot here. The program would have drawn a line through the points rather than showing you the daily means. But this gives you a sense of what the data looks like, and you can understand the signal. But the point of this problem is to in fact do a quality control chart. So the way that you do a quality control chart is you go to the Analyze menu, Quality and Process, Control Chart, and X bar. So that is the group of commands you want to follow through. So you click on X bar, and you now get the dialog for the X bar chart. Now what you have to do is tell it what you would like to track, and in this case it's rating that you're going to track, so that's the process you're following. You have to tell it what you're going to track it by, which is day, and that goes in as sample label. Over here by default it will do the X bar and R charts, but I don't want it to do an R chart, I want it to do an S chart instead, so I'll click on that. In terms of these parameters here, this is how the upper and lower control limits on the control chart are defined, and we'll take the default, and these will be 3. K is equal to 3, so we're going to create limits that are plus or minus 3 standard errors from the mean. Remember, that gives a false positive rate of about 3 in 1,000 from the empirical rule. Now, the final thing that we have to do in this dialog, because we have a process mean and process standard deviation available from the context of the question, those have been given to us a priori, and that's that the underlying process mean is historically 8 with a standard deviation of 1.2. We click on Specify Stats. Into sigma, we type in the standard deviation, not the standard error, the standard deviation, and into mean parentheses measure, we put the process mean as we believe it has been. And now I have the dialog completely filled out. I just have to click on OK, and here are the two charts that I want to have a look at, the X bar and the S chart. So the top one is the X bar chart. It is tracking the daily sample means, and you can see within this period of about a month it's gone from an average of 7.7 up to 8.4. Now the upper and lower control limits are placed around the green line. The green line is the process mean that we specified at 8, and you know that we specified it because it says mu naught is equal to 8. So that's not coming from the data, that's coming from a population parameter, and then it's calculated these upper and lower control limits by looking at 3 standard errors from the mean. Now in this particular example, the standard deviation was 1.2. There were 100 observations per day, and therefore the standard error is sigma over the square root of n. In this case, 1.2 divided by square root of 100, which is 10. 1.2 over 10 is 0.12, and when you multiply that by 3, you get 0.36, and hence 8 plus 0.36 is 8.36. So that's the upper control limit. So when I look at this X-bar chart, I would note that there is a very strong trend in the context of the problem. Browser ratings are increasing over this time period, and formally it moves outside the upper control limit at the end, so we're going to call it the process not in control. The second chart is the S chart, which tracks the sample standard deviation each day, and the green line here is the reference line. The construction of the S chart is fundamentally more complicated than the X-bar chart, so I'm not going to dwell on its construction, but its interpretation is something you should be able to do. And what we're looking for here is trends or cycles within this process for the standard deviation, and I don't see any. It's very, very stable, and furthermore it lies within the control limits. So in this particular example, the mean is not in control, whereas the standard deviation appears to be in control. Overall, we'd call the process not in control because one of these, the X-bar or the S, potentially both, but not in this case, just the X-bar has failed the control test, so the process is not in control. And that's how you create the quality control charts in JMP.